Hi, I'm Spencer Banta, and welcome to the Wavetronics webinar. Thank you for joining us. I'm excited to talk about making more efficient intersections today. Feel free to share this link with your coworkers or other people you think would be interested. We'd love as many participants as we can get on this. We'll also be recording it though for your reference, so that you can reference back to this or ask any questions that you might have. As we go through the presentation, you might have some questions. We have different spots along the presentation to be able to answer those questions. So you should see right below a little question and answer bar right below my face here to be able to ask those questions. If you're having any problems with that, your browser isn't compatible or something, then you can go ahead and email me at spencer.banta@wavetronics.com, and I've got my stuff set up here to be able to field those. All right, well, let's hop in here. So accurate detection at the intersection is foundational for what the industry coins smart intersections or intelligent intersections. Today we're going to talk about how we can make your intersection smarter using the SmartSensor Matrix. We'll talk about how your agency needs detection that can grow with your agency. Everywhere you look in the industry, you see smart. Smart this, smart that. Wavetronics has been doing smart sensors for a long time. So let's talk about what we hear customers think is smart and apply it as it suggests, and suggest a plan the customers can take to implement more smart applications. The goal of most traffic engineers, almost all in agencies, is to have system-wide control for safe and efficient intersections that they can control as an entire system. We've approached some of the agencies that are implementing system control and asked them how have they done it. And they've created a traffic signal operations pyramid to help us to kind of know what are the steps that go into achieving system-wide control. One of the things that we hear most frequently is good local control. Local control in an intersection means that the intersection is working well on an intersection by intersection basis. It also means that engineers are trusting their timing plans, that the equipment is properly detecting, that it's properly preempting, that splits aren't too long or too short, and it's flowing and traffic is flowing well. But there are two giant hurdles to getting there that the SmartSensor Matrix, which is a product we'll be talking about today, helps with. And we're gonna talk a little bit about that. One of the giant hurdles that traffic engineers face is maintenance. Agencies that are swimming in work order after work order to fix inept equipment find themselves unable to get control of their local system. They spend more time being reactive, and that makes it so they have less time to be proactive to implementing new things. So maintenance is one of those big hurdles. The other big hurdle is getting the right equipment in place. So foundational to the traffic signal timing and operation, the traffic signal and operations pyramid, is installation of detection equipment that works and a good way to communicate and monitor with those intersections. Some agencies have gone quarter by quarter to do this, maybe with an adaptive or a traffic responsive system. And other agencies have gone and started just improving an intersection, getting the right equipment in for detection and communication, and then building from there. Both seem to work well, and we're going to talk a little bit about today how having the right detection in place can really help improve your local control. So the SmartSensor Matrix is key to doing that. So some of the applications we're going to talk about today are going to be using long detection zones, getting vehicle counts with the same equipment, flashing yellow arrow applications, and then another one that we'll call red light monitoring, red light runner monitoring that we're going to talk about today. Before we go into our first application though, I want to explain how the underlying technology works, so you can understand why the SmartSensor Matrix can do these applications that some other products might struggle with. So to help you understand that, I want to describe what's going on here in a brief video animation. This is a typical mounting location for the SmartSensor Matrix, but let's talk a little bit about how radar works. Basically, the radar transmits an electromagnetic wave that bounces off the vehicle. You can see that the green is the transmit, and that yellow is just showing the receive. And so as the signal comes back to the sensor is able to range how far away that vehicle is from it. The SmartSensor Matrix that we're going to talk a little bit more about is unique in that it's very good at ranging and also at telling where vehicles are and the angular resolution from the angle of the sensor. Notice that there are 16 different antenna beams that are coming up here. These 16 different antenna beams are working together to accurately detect and then to range that vehicle. We've slowed this down for the animation, but as you can see, the beams go 3,000 times a second. Notice that yellow response area that now just turned red it's very easy for the sensor to see where that is. Wavetronics calls that true presence radar detection. Now we've removed the beams and just showing the return off the vehicle, so you can get an idea of how it looks when it's bouncing off the vehicle. Notice the red spots on the vehicle. Those are what we call the brightest spots on the vehicle, and those are responding to the sensor there. Now we've removed the vehicles and are just showing what the sensor is reporting. If you've seen our UI, you see a little blue tracker that's going in there. Where that blue tracker is the highest, is where the brightest point is on the vehicle. And here's the UI next to the animation there. So you can see that we can tell cell by cell where the vehicle is traveling, and then output to the controller via contact closure the presence of a vehicle in an area. And so that animation kind of helps show some of that. So the SmartSensor Matrix is a great vehicle detector. The radar beams can accurately detect vehicles within 140 feet of the sensor. It has flexible mounting options that we'll talk here about in a minute, and can handle up to 16 different channels per sensor. That's a lot of channels, but we'll talk about how you can use them and what things they can do. The Matrix's ability to detect vehicles is uncanny in the traffic industry. So here's some of the places that the sensor can be mounted. A is the most ideal place to mount the sensor. Just for your quick reference, B is also a place that's possible. You know, there's a lot of intersections that don't have mast arms and they just have upright poles with span wire. In that case, you could mount on B or on C that you can see over there. And they just ballpark point the detection back towards this target detection area. So notice we're mounting on the same side of the approach, not across the approach. We're on the same side there. We have a team of application engineers that are available to help in any design work. So you can email them at support@wavetronics.com, and they'll tell you, oh, this is where we recommend putting the sensors for this specific intersection. You can set them on Google Earth. We have some overlay tools for your plans and different things like that. So the guys at support@wavetronics.com can definitely help you with that. Now, to get the detection back into the controller, let me just describe how that happens very quickly. We use an RS-485 cable that runs from the sensors back to the cabinet, and then there's a Click 650 or a Click 656. The Click 650 can handle 4 sensors, and the Click 656 can handle up to 6 sensors. So the Click 650 or 656 communicates via SDLC to the controller. So the controller does need to be a NEMA controller in most cases. There are some controllers that are 2070 controllers that have the 2E I/O card that have the firmware running to be able to also receive contact closure, or to receive over SDLC. There's some pinout work. Anyway, our people at the support can help you with that. So we're going to jump now into the first application, that's long zone detection. This is a quote from the Signal Timing Manual. The use of a large 80-foot detection zone allows the passage time to be reduced to 0, creating more efficiency, prevents premature termination of the phase due to sluggish traffic, and allows for immediate termination when the vehicle passes the stop bar. Long detection zones are more efficient than small detection zones. We're going to dive into the math a little bit here and talk a little bit about why. But first, we're going to talk a little bit about passage time. So the goal of passage time is, there's really 3 of them. The first one is ensure queue clearance. The passage time should not be so small that the resulting maximum allowable headway causes the phase to have frequent premature gap outs. A premature gap out will leave a portion of that stopped queue unserved, and thereby lead to an increased delays and possible queue spillback. So ensuring that the queue is clearing is one of the original important things of why passage time came to be. The next one is to satisfy driver expectations. Passage time shouldn't be so large that the green is extended unnecessarily. We don't want waiting drivers and conflicting phases to be anxious or disrespect the traffic signal. This happened to me just the other day. I was at an intersection, and being a traffic person, I feel it's very important that people follow traffic things. And the person next to me, they had gotten the corresponding phases gapped out and went to red. And this person just started pulling into the intersection, even though we hadn't quite received the green light yet. They'd just gotten so used to snappy intersections that they started pulling out even before they had the chance to, before we got the green light. And so we don't want drivers to disrespect us. We've got to figure out the ways to minimize, to satisfy the driver expectations. And then the last one is to reduce max out frequency. The less we max out, the better. And so passage time shouldn't be so large that the MAH causes the phase to have frequent max outs. So those are the three main reasons, the three main things that passage time does. So the signal timing manual helps us to be able to calculate some of that information with some illustrations, and we're going to go into some of those right now. So we have here, there's this little image here that shows the length of the vehicle, length of the detection zone. We show the gap, we show the maximum allowable headway, and then there's an equation for passage time, right? So passage time, as you well know, equals the maximum allowable headway minus the length of the vehicle plus the length of the detection zone over 1.47 times the average speed. So once we put all these things together, luckily, there's some good engineer that's like, hey, let's just put this in a table, right? And we all love tables. And so the table shows the detection zone here on the left side, the speed on the top, and then what the passage time should be below. Notice that when the detection zone is longer, 60 to 80 feet long, we can really lower that passage time, making our intersections a little bit more efficient. So basically the three goals of passage time, ensure queue clearance, satisfy driver expectation, and reduce max out frequency, can be achieved with long zone detection and a smaller passage time. And that's something that we want to get to, a smaller passage time. So here's an example of a time that this can kind of help here. So we have just a normal queue of vehicles that have just gotten the green light and they're pulling out. For some reason there was a delay. Maybe the truck didn't see it, maybe the car was on their phone, whatever it was, but it made it so that when yellow occurs and then the red, that the entire area wasn't serviced. It gapped out prematurely. Now this is just an example, obviously, but this does happen on our roadways. And then the difference is with the long detection zone. The long detection zone, we can, being one of the reasons that the SmartSensor Matrix mounts on the same side, is that same traffic now that flows through the approach will all get detected and it will continue to extend, right? So we'll extend, oh, I see that there's a car here. That's one of the reasons why we recommend the A and B mounting location there by the left-hand turn. We see those vehicles, we extend for them until all the vehicles have been serviced, and then we gap out. This is specifically useful in minor movements. We'll talk a little bit about that in a minute. But long detection zones should be 65 to 85 feet. 65 to 85, even bigger, right? Whatever you wanted it to be, but they should be longer than your normal typical dilemma zone. And they can go over an entire approach. So let me show you in the SmartSensor Matrix software how you would set up a long detection zone. So you would go use the zone template. You would just enter whatever it is. And this template that you're creating can be used in multiple intersections as well. So we do long detection zone stop bar, click and add the zone, select the lanes that exist, and then we're going to say that this one's 65 feet, and we're going to put it 3 feet in front of the stop bar, just for those creepers that are pulling right up over the stop bar. And then we would set up the zones like that. And so now those detection zones would output continuously when a vehicle was inside of them. Now, one thing that you want to take into consideration when using long detection zones is your use of advanced detection. If your advanced detection is set to extend passage time for vehicles to the stop bar, you don't want to then extend the call at the long zone. So consider using a presence type zone only. That's a controller setting in most controllers. Or what you can do is maybe add a speed filter to some of those zones so that if they're going under a certain speed, then it would only output. But the minor movements will almost always benefit from a long detection zone. So other non-intrusive devices are mounted across the roadway from their detection area. One of the reasons traffic engineers, I think, loved loops for so long was because of the vehicle's location would accurately be known within a few feet. When there was a vehicle within a couple of feet, then the loop would be triggered. Wavetronics recognized the best way to emulate this technology was to mount on the same side of the road as where the vehicles are, making it longer detection zones more accurate than maybe some of the other technologies that exist. So the next application we're going to talk a little bit about now is counting vehicles. Intersection counts is a key component of accurate timing in most systems. The SmartSensor Matrix allows you to get vehicle counts in individual lanes. We typically put the counting zones just in front of the stop bar. So you can see there on the image there where we kind of suggest you put the intersection detection zones. I'll show you how to configure them here. But we've recently come out with the Click 650 and the Click 656. These devices can store some of that counting data and also provide some analytics. The Click 656 on the right side there and the Click 650 on the left side can handle up to 64 channels of detections. So that's a lot of channels. Some of these features are going to talk to a controller, going SDLC out of the Click 650 and Click 656 right into a NEMA environment, or as I mentioned earlier, some 2070, 170 environments. We have a group of application engineers that are happy to assist with helping you know how it would work in your specific system. To kind of show you the size of the Click 656, here's just a quick image of it. It's about 3U in your cabinet, so you can kind of get an estimation of the size that way. So it fits relatively well into most cabinets if you have that much space, and then if you have SDLC out, you can really get a lot of channels of detection in a smaller area. Let me show you how you would set up a counting zone in the SmartSensor Matrix software. So the first thing you would do is create a new channel like we did before. You would name the channel. So this one we were going to show both the stop bar and the counting zone at the same time. And so you would add, like we did before, the 65 feet, and then -3, just a little bit ahead of the stop bar again. We'd add another zone, and we would call this zone counting, right, or counting channels, or however we wanted to do that. And then we would choose whichever lanes that was associated with, so the left hand straight through and the right hand. And then we're going to put this counting zone again just in front of the stop bar. So we're going to say the zone length is 5 feet, and it's going to start at -5 feet. So there are all the channels. Notice zone 7, zone 6, zone 5, and zone 4 are all counting channels now. Again, just to iterate how the calls go back into the controller. So the sensor will put the call through to the Click 650, and then the Click 650 can actually pull some phase data from the controller and then output the calls into the controller. So it's kind of a two-way communication there, and that allows us to get some pretty cool analytics. So for example, here's one of the things that you can get from the Click 650. It's the data summary table. So on the left-hand side here, you can see the BIU that's available. So BIU 10 there, and then whatever detector channel corresponds is in that BIU with the description of it. And so then we can look here and see how many times was that activated or actuated, and then we can see there were that many calls. It can also get into a little bit deeper analytics. Well, what was our arrival on green percentage? And then on top of that, how many cycles occurred in that detection area. So, with a little bit of, you can also export this. So with a little bit of macro development, you could be producing whatever charts you wanted in a very short time. We also provide some basic graphs and charts. And so this is another one that we have that's just a count details chart. This is really more of a troubleshooting graph. You can compare counts over the day and see when fail-safes have maybe triggered to make sure that your detection is working correctly. It's especially helpful when you have intersections that were problematic and you want to show a positive change when you put in maybe new detection. And so that's that graph there. We have one other graph that's available in the Click 650 that's also very good. It's called the arrival profile. So the arrival profile is a really cool one that's typically used with the SmartSensor Advanced, but I want to talk briefly about it here because we're going to chit-chat a little bit more about it. But a detection zone is placed about 350 feet or more, about 350 feet away from the intersection, and the vehicles are measured as they come up to the approach. So suppose the intersection is in the middle of a coordinated system, you can use the arrival profile to make sure that your platoons are arriving at the right time throughout the day. So this chart shows the start of red and it goes all the way back whatever starts at red, and then it goes back, maybe 2 minutes. And you can see how many vehicles arrive on the red portion and how many vehicles arrive on the green portion throughout the day. So it's kind of a different take on what is your arrival on green or arrival on red throughout the day, and how does it compare. And so that's kind of a good, cool chart as well. All right, at this point, I'm going to look to see if we have any questions here that have popped up for this slide. Let me refresh here. Doesn't look like we have too many. But one that I frequently get is, how well does the SmartSensor Matrix detect bicycles? So coming back to this slide here, I wanted to show this. So there's the bicyclist here. So I wanted to show specifically the cells. So these cells can be 2 feet tall by wideness gets bigger as it goes out. So it starts really close, about 1 foot, and then it can get up to about 6 feet out here. So when we're detecting bicycles, the key is that a bicycle needs to be a certain distance away from a car, and it's typically about 2 cells. So if a bicyclist pulls up and it's right next to a car, we maybe would merge those detections together because it's under that resolution. But if a bicycle pulled up by itself and it was more than a certain distance away from other vehicles, then we wouldn't have that problem, and we'd be able to get right through. We'd be able to detect the bicycle and put a call into the controller when it was there. And so there's a lot of agencies that are using the SmartSensor Matrix for that as well. All right, let's jump on to the next one, flashing yellow arrows. So to just talk a little bit about flashing yellow arrows, we first need to talk a little bit about the yellow trap, just to make sure everyone understands that. You probably are well aware. I did have a question pop in here that was related to what I was just talking about. The question is, how does the Matrix detect small vehicles behind the larger trucks or bus? All right, so I'm going to go back to that slide again because that's a good question. We're talking about occlusion. So if there's a vehicle so mounting location is key for the SmartSensor Matrix. If we put the SmartSensor Matrix in a location where occlusions frequently happened, then it wouldn't detect. So for example, if this bicycle here was behind that bus, it wouldn't see that bicycle was there. But what we do have in the SmartSensor Matrix that's unique to our product is we have this 140-foot footprint that kind of goes around the entire approach. So even if there's this big semi-truck right here, if a car started pulling up back in the, let's say that front left-hand turn lane, if a car started pulling up back in this region, then what would happen is we would see that vehicle back there 140 feet away, and we'd be able to track it to the intersection. We then have some anti-occlusion algorithms that will be able to say, okay, well, that vehicle, there was a vehicle there, it didn't just disappear, and then maybe we would detect it as it got closer to the stop bar and maybe pulled in front of that semi. But it's not going to be able to bounce around a vehicle. It's not going to be able to, see past vehicle. We can only see the vehicle when we can see the vehicle. But our customers report that the occlusion, if you choose the right mounting location, isn't much of an issue. And then also it kind of comes into the design. So if you have a leading left, for example, then maybe you would want to be more in the A and B detection area here. Whereas if it was a lagging left, you could probably get away with a C detection area. So as long as the sensor is positioned correctly, occlusion doesn't have much effect on it. So good question. Thanks for asking. We have one more here that came in. Does it replace a ground loop detector and allow flexible detector zone based on traffic pattern throughout the day, such as off-peak? That's a good question. So there is some flexibility that you can do in the creation of your zones. What you maybe would do is just create a different zone that would call the controller at the right time. I maybe will, if you send me an email, I might talk to you a little bit more about that one. That's getting off a little bit of what we're trying to go on. But this flashing yellow arrow zones can kind of allude to that. So we're going to keep going here and we can get into that a little bit more. So let me talk a little bit first about where I was with the yellow trap. So we all kind of understand what the yellow trap is, right? But I'm just going to go over it quickly to make sure. Basically what happens is we have two conflicting approaches, or opposite approaches really, that are both green. There's a car that's trying to make a left turn that doesn't necessarily feel able to make that left turn, and so they're kind of waiting for the right gap. And so what happens is the light turns yellow on the driver, and they assume that both sides have a yellow light, but they don't. And so that driver continues to proceed through the intersection, and then because this approach didn't have a left turn, or a yellow light, they didn't stop, they run into the driver, and it causes an accident. So years ago, they found that, hey, using flashing yellow left-hand turn arrow can tell drivers that they can continue through the intersection, but they need to do so with caution, removing the assumption that drivers' minds, the drivers will gap out at the same time, or that. So that flashing yellow arrow is just a proceed through with caution. But the detection can change a little bit based on this as well. Let's say you wanted to get a green arrow. So let me show you a little bit here. So when you're doing detection zones for a flashing yellow arrow, you want to place the zone where the third car back in the queue would sit at this. So for example, it's at where the green square is at this intersection. Although at the top here you can see that it's a double left. I would be cautious about using a flashing yellow arrow on a double left. You wouldn't want to do that. You'd really only want to do it on single left-hand turns. So you put that zone about 50 to 65 feet away, and then you put a 3-second or so delay on it as well, so that if that is occupied, as you'll see with these vehicles, they'll get a green arrow, and then they can go. If it's not occupied, then it won't get a green arrow, and those two cars will be able to sneak through on yellow. So in the controller, you have to make those changes. You have to go in and change it to be lower, add a delay of about 3 seconds. But you can also get some of the efficiency with a long zone detection. So let me show you how you would set that up. So on the controller side, so you could add 2 detection zones, right? So one of these detection zones would detect the queue. Another one would detect the vehicles. One of the great things about the SmartSensor Matrix is if you want to just tweak it and move it a little bit, you can move the zones very easily. It's not a permanent installation. Well, it could be a permanent installation. This is what I mean, though. Let me show you here. You can adjust them. It is permanent once you set it, but if you wanted to make a change to the zones, you could make a quick change to the zones. Oh, I want to move that forward a little bit, move that back a little bit, based on the traffic flow. And so here, I'm looking at the range, and I said, oh, it's only 44 feet, and I really wanted it 50 feet. So I can kind of grab those little nodes there, and I can move them back a little bit, and then I can move that other zone a little bit as well, just to make sure that it's going to detect the third car back, and we'll get that. And with that delay, that's going to make that intersection run pretty snappy. All right, and then the last one's kind of a Webtronics hack. It's called red light running monitoring, and we're going to talk a little bit about, red light running is a serious issue. This product isn't really the product to help prevent red light running or dilemma zone issues, but it can measure the number of occurrences that occur. If you were looking for a product to help fix your dilemma zones, we have another webinar on our YouTube channel about dilemma zone protection. You could watch that one, and it would explain how a different product that we have, the SmartSensor Advance, which is one of my favorite products, can help protect vehicles as they come to the intersection. But we're not going to go too much into that one. So to set up a red light runner monitoring system, or at least count them, what needs to happen is you need to place a zone very similar to where you would place a counting zone, just in front of the stop bar. But because we're using radar, we can detect the speed of the vehicle as well. And so what we can do is we can just add a little filter onto there and say, only put a call into the controller, or count, basically count the number of cars that would go when the speed is going faster than, say, 15 miles an hour or 20 miles an hour. And then because we're getting data from the controller, we can then say, when it goes red, indicate that that's happening as well. So let me show first, before I get to the controller part of it a little more, let me first show you how you would set that up in the SmartSensor Advance. Or sorry, in the SmartSensor Matrix. So this would be the full detection setup. So we're going to add zones, and the first one we're going to do is, again, we're going to add our stop bar detection. The nice thing, again, is we're creating a template, so you can have some standard as you go intersection to intersection. You'll be able to make sure that all your intersections are kind of detecting the same way. which is greatly beneficial for troubleshooting, training your technicians, making sure everybody's on the same page. So I got that stop bar long zone detection one created. Now we're creating the counting zones. And again, we're going to put it about -5 feet. So 5 feet in front of the stop bar is how we do negative. And then we're going to add the red light monitoring or red light runner counting channel here as well. And so you can just add the different channels. And then we do the same thing where we drive to -5 feet. And then we would be done with that. And so we would have all the maximum number of channels set up. Put this one a little bit more into the intersection, because that's something we do want, we do want it to be in the intersection a little bit more. And then notice now we have our 3 through lanes, our counting channels, and then zone 11, 10, 9, and 8 being our red light running stop bar. So this is what it looks like in the Click 650 on the arrival profile. So notice that this little red graph here, within the first 5 seconds, which is good because we don't want to see any 10-second red lighters or something like that, but there were about 16 red light runners through the course of that day, looking at that one specific channel. So back to this little graph here, if you just want to do one giant zone over the entire thing, you could. Now obviously you wouldn't want to do it on a right-hand red type situation. You wouldn't want to put a speed filter or a counting, maybe a counting channel, but not a speed filter with counting channel, so the red light monitoring there in the right-hand turns. So that's how you use some of that. All right, time for questions again. We did have a couple more come in. One of the questions is, what is the minimum height installation requirement? So the minimum is 12 feet, but we typically recommend about being at least 15 to 20 feet. That would be like the absolute minimum, but when you're at 12 feet, you're not going to be able to see over other vehicles, right? So getting it on a little extension would be good. It doesn't have to be way up in the air. Typical installations is about 20 plus or minus 5 feet is typically where it is. 20, 25 is pretty reasonable. And then there's another question here that was, may I ask you, how do you film the intersection turning movement? It looks very nice. Well, we got a sweet drone. So our friend Stephen Bills here at Wavetronics is a drone expert, and he makes some really cool shots. So props to him on that. And I think the questions, let me see if I had any on my email. No, I didn't, but feel free to email me as you have more. Let me kind of got a couple more slides here to show before we wrap up. So UDOT this is an example of their full detection setup. And so it isn't uncommon for agencies to use all the different zones and channels that are available for them. The agencies have been kind of strapped in the past, right? You'd have to have a rack card, and then that would add to the expense. But using SDLC communication and you can get 64 channels of detection with relatively less equipment than what it used to be. And so you can do a lot more of these applications to make your local control much better. And then that will, of course, spill over into your system control once you start measuring and getting some performance out of how well your intersections are going. The things we talked about today really focus on local control and how you can make your local control better. And the things we learned because we were able to get to system control, and then with some agencies, and so then we said, they said these are our favorite applications that work well with your product. And so we wanted to share those with you today as well. And then, so here's just another quick shot of all the different zones that are possible. So up to 13 channels here that we could be using for the detection area. So it's a lot, but the SmartSensor Matrix really can provide some ease there. And configuring them is a breeze. They're really accurate and reliable in their detection, and it's become the standard of many agencies. One successful story comes out of North Carolina. In Greenville, North Carolina, the city is replacing loops with the SmartSensor Matrix for stop bar detection, and it's saving a lot of tax dollars, and by reducing the maintenance costs as well. So Richard from the city of Greenville, Greenville traffic engineer, who actually signed up for this webinar, so he might be on right now. But he said, we're always looking for ways to do things better and more cost effectively, and the SmartSensor Matrix makes that possible. With the Matrix, we really are getting more for each taxpayer dollar by leveraging the safety and mobility, data collection and cost, and time-saving benefits it provides. So not only is Greenville saving money on maintenance, but they're starting to see the benefit of how the SmartSensor Matrix can help bring improvements to safety, mobility, data collection, and more. So lastly and foundational, the traffic signal pyramid is getting over the humps of installation and maintenance. And then we've kind of given some of the more exciting things today about the local control, things that you can do. And we invite you to come and talk to us about it. We got offices all over the U.S. and all over the world. And then we sell through a distributor network as well in some territories. So if you need help getting the right person, just send me an email, and I'd be happy to get you to the right group and introduce you to the people that live in your territory or in your area. And we'd love to help you with that. I think we got to let me check for a little bit more questions here. We have all right, so we have a couple more questions here. One of them is, can we get a copy of the video to replay for our field techs? Yeah, you can. We'll actually probably do, we're talking about doing a webinar for technicians specifically, explaining more of the mounting, how to configure it, doing a little bit more of that. But we'd be happy to get you this video as well. So we did record this, and we'll send out a recording of it to you after the presentation. And also, I'd like to ask that if you have suggestions for future webinars, send me an email. We'd love to take that as a consideration, or and make a webinar based on some of the things that you would like to see. So thank you very much. I think that's all that we really have for you today. Keep those roads moving, traffic engineers. Thanks, and we'll see you again next time.